to our basic science class. In our previous class, we discussed simple machine and we took two parts of that episode. If you've not watched it, go back and watch it. Today we are going to look at type of energy, and particularly the type of energy we are going to look at is kinetic energy. Kinetic energy. And then we'll look at the assumption of the kinetic theory. So we have two objectives for the class. Define kinetic energy, state the assumption of the kinetic energy. Now let's look at the first objective, which is define kinetic energy. Kinetic energy is defined as energy possessed by an object due to its motion. An energy possessed by an object due to its motion, or the amount of energy an object has as it moves around the system. The energy which an object has as it moves around the system. Now let's make it clear. When we say kinetic energy, it's energy possessed by an object due to its motion. What is motion? Movement. Let me use this as an example. A car that is in motion, a moving car, possesses kinetic energy because it is moving. The motion that it has, or the motion that the car is on, is a kinetic energy. An object, a moving object, has kinetic energy. A car that is moving possesses kinetic energy. Then, a bicycle, you climb a bicycle, you are applying force to move it. The rolling of that bicycle, or the movement of that bicycle, makes the bicycle to possess kinetic energy. Then, a rolling ball. You play a ball and it's rolling. The act of rolling makes that ball possess kinetic energy because it's moving. Because of the force you've applied to play it, it's on a rolling way. And so that rolling, the ball rolls, makes the ball to possess kinetic energy. So a moving car, a moving bicycle, a rolling ball possesses kinetic energy. So we can say that motion is equal to kinetic energy. Motion is equal to kinetic energy. So the motion, the movement, makes that object possesses kinetic energy. And the formula for it is kinetic dot energy equals to half motion velocity square. Don't worry, when we have a problem to solve, we will apply this formula to solving a problem under kinetic energy. So assume that the car, which is the motion the car has, is given, the velocity it moves is given, you will be able to impute it and give the kinetic energy. Remember that it's measured in joule. Its SI unit is measured in joule. Alright, so kinetic energy is an energy possessed by an object that is in motion. Kinetic energy is an energy possessed by an object due to its motion. Or a car that is moving possesses kinetic energy because it's on motion. A rolling ball possesses kinetic energy because it's in motion. Now let's look at some assumption of the kinetic theory. So you have known what the kinetic energy is. Remember, we're looking at types of energy, and kinetic energy happens to be the class we are taking, the number one of the energy we are going to talk about. Let's look at the assumption of the kinetic theory. Look at our third objective, state the assumption of the kinetic theory. Now, under this assumption, we are going to talk about a number of points. Here we will talk about 4 points, 5 points or more. We'll use this verse to explain the movement of molecules. Now, the number one assumption is that large number of particles are in random motion. Large number of particles are in random motion. Let's say this is an ideal gas in a bus. These are particles. Now, if you look at their direction, you see that they are not in a direction. They are in random motion. And they can be in different sizes and different shape. They don't take a similar direction. So, number one assumption said these particles are in random motion. They move randomly. They react randomly. Assumption number two is that they are in constant movement, are constantly moving. If you look at this ideal gas bus, you see that the particles in here are in movement, are in constant movement. Because they don't move in the same direction, they are always moving at their own direction. Remember, they are microscopic substance that cannot be seen with our own eyes. Then number three, have negligible volume. Have negligible volume. If out of this ideal gas box we have, if I remove one particle or a molecule from this, it's negligible. You see, I've removed one. It is negligible because others can carry out the activity. So a removal of one out of the volume is negligible. Alright? It undergoes perfectly elastic cohesion. That's to say, no loss of kinetic energy in this instance. No loss of kinetic energy. Remember, kinetic energy results in motion. And so, undergoing perfectly elastic cohesion makes it, the elastic nature here shows that no loss of kinetic energy happen as a result of this. Okay? Then the next assumption is that there are no forces between particles except during cohesion. The fifth one, have an average kinetic energy proportional to the ideal gas absolute temperature. To the ideal gas absolute temperature. So, let me run through the assumption again. You can go through it. Large number of molecules in random motion. Large number of particles, large number of particles in random motion. 2, they are constantly moving. 3, have negligible volume. 4, undergo perfectly elastic cohesion, and this perfectly elastic cohesion means that no kinetic energy is lost, no loss of kinetic energy in this instance. This does not lead to loss of kinetic energy, and you know what kinetic energy means from our definition of what kinetic energy means. And then there are no forces between particles except during cohesion, have an average kinetic energy proportional to the ideal gas. So we have seen the different assumption that goes with kinetic energy. And since we are looking at types of energy, we look at the other parts or different types of energy that will come under this kinetic energy. Remember, we have 2 objectives for the class, and we've been able to meet the 2 objectives. We've told you the meaning of kinetic energy, and we've stated some few assumptions of the kinetic energy. In physics, there are some studies that we undergo. That means that these things cannot be visible to the human eyes. Like when we talk about atoms or molecules, these are microscopic elements that cannot be seen with the physical eyes. And so that's the assumption. This is your basic science class for JSS2. Come along as we take further subtopic under this. It was a pleasure having you on the class. Subscribe if you've not subscribed. Ask your question if you have question. I'll see you in our next class.